The average value theorem, sometimes and rarely referred to this way, but the mean value theorem for definite integrals. And you can read it here. If you have a continuous function, notice the only requirement is continuity. You don't have to have differentiability. If you have a continuous function, if you want the average value, the average y coordinate on a closed interval, this is the formula you will use. The antiderivative, essentially the antiderivative from a to b divided by the length of the interval. It's usually written as 1 over b minus a times that. And so we're going to look at a few of these problems, and all of these are calculator active. And so the first one is a continuation of a problem that we did on one of the other theorems in a different video, but the rate of water flow running through a pipe can be approximated by this function, and we're using this function to approximate the average rate of flow during the 24-hour period. And what I cut off when I wrote this question by separating it from the rest of the free response question, this is on the interval 0 to 24. So we're on the interval 0 to 24, and we're wanting the average rate. Now, whenever I see the average rate of change, the average rate is old-fashioned algebra 1, change in y over change in x, if you have the original function. But here we don't have the original function. The function we are given represents the rate of water flow. And so R is the rate, and we want the average of the rate. So we want the average of this function on 0 to 24, and the average of that function would be the average value theorem, 1 over 24 minus 0, antiderivative. And in a free response question, if they define the function, in this case it's q of t, if they define it as q, just write down q. Don't feel like you have to copy the actual equation, because we're going to throw this in the calculator anyway. And if you try to copy the equation, there is the slight chance that you may just brain fart and accidentally write plus t squared or something like that. And in that case, you might lose a point for the setup, for a slip of the pen. And so I'm going to write down my setup, 1 over 24 minus 0, times that antiderivative, and then I go straight to my calculator, and I'm looking at my calculator here, and the answer is 10.7848. 10.7848. Now, on the AP exam, they accept 2 interpretations of that. You must be accurate to the third decimal, so 10.785 would follow standard rounding procedures. However, they also accept the truncated version of 10.784. It doesn't stress, oh, never mind, indicate units of measure. So now we need to indicate units of measure, and we are finding I cut this off too. I didn't think this out. I believe this is gallons per hour. Because we are finding the rate, and this is my fault because I typed and separated this problem from the rest of the free response question, and the units that are provided are in another part of the problem, and I forgot to copy that down, but I'm pretty sure that the rate is measured in gallons per hour for this case. I need to fix that. Oh well, I don't feel like it. All right. Let's move on another calculator problem. This is another a snippet of a free response question. I believe this one's from 1998, but we have a function that represents the temperature outside a house during a 24-hour period. And then they ask for the average temperature. Well, this function represents temperature, and we want the average temperature between 6 and 18. So that's going to be 6 and 14. So that's going to be 1 over 14 minus 6, antiderivative, 6 to 14 of that temperature, which is represented by f of t. And that answer is 87.1619, which, again, like the last problem, we can follow standard rounding procedures of 87.162, or they would accept a truncated version, which means you just write down the first 3 digits and you stop. And the units in this case would be degrees Fahrenheit, because that is how we are measuring temperature here. In the last question, we have a table of values. They tell you that the function is continuous. P of t represents the number of shoppers in a store, t hours after opening. The store is open from 8 a.m. to 6 p.m., which would be from t equals 0 to 10. We have select values of t. Okay, here we go. Finally, the question. Use a trapezoidal approximation with three intervals indicated by the table. So that'll be the interval from 0 to 3, 3 to 7, and 7 to 10 to estimate that value and explain the meaning and the context of the question. So let's do the estimation first. So the estimation would be 1/10. Actually, I'm going to write down the interval. 1/10, 0 to 10 of p of t dt would be approximately 1/10. Now, the trapezoidal approximation only addresses the definite integral, not the 1/10. So make sure you keep that 1/10 out front. And then the trapezoids, these delta x's from 0 to 3, 3 to 7, and 7 to 10, the delta x's are inconsistent. So we would have to measure these trapezoids individually. And so the area of a trapezoid is 1/2 the height of the trapezoid times the sum of the bases. The height of the trapezoid is the delta x. And the bases are the function values. So it's going to be 1/2. My first trapezoid height is 3. The sum of the bases is 0 plus 15. My next trapezoid is half the height, which is 4. The sum of the bases, 15 plus 21, plus the last one, half the height of 3. And the sum of the bases is 21 and 12. And as far as the AP exam as far as the AP exam goes, that answer is acceptable. You do not have to simplify that. You don't have to clean that up. You don't have to write down a nice, clean answer in the end. And usually I will stop here because I don't want to screw it up. I don't want to do something that makes it wrong. However, in this case, it is advantageous to at least punch it in your calculator and look at the answer, even if you don't write it down, because you should be able to anticipate the answer. We're finding the average value of the function, and the values we have so far are 0, 15, 21, and 12. And so you can estimate, or you can look at those numbers and figure that the average is probably somewhere around, 10 to 15, I guess. I don't know if you added those up and divided by 4. I'm guessing you get an answer somewhere around 10 to 15. So I'm going to throw this in the calculator. And when I did, I got an answer of 14.4. And it helps me to do that because 14.4 is a very reasonable answer for this set of data. And it makes me feel good about my answer. And so I got an answer of 14.4, and I like that answer. That fits the data, whatever you want to call that. And so there's my answer. But then there's the explanation. What does this mean? And you need to recognize that the definite integral with that little fraction in front is a reference to the average value theorem. That is a reference to the average value theorem. And what you need to remember is when you're explaining your answer in the context of a problem, you have to be very specific. Restate all numbers, all intervals, include units, be very detailed. And so if I'm going to explain this answer, what I found was the average value of P of t, and P is the number of people in the store. And so my explanation is the number of people in the store, and I need to reference the interval. We went from 0 to 10, so you could say from t equals 0 to t equals 10, or you could say from 8 a.m. to 6 p.m., some reference to the time that we looked at. Because we use 0 and 10 in the actual written math, I'm going to use those. I'm going to say from t equals 0 to t equals 10 is approximately, because a trapezoidal sum does not give you the exact answer. We had to do an approximation method. So the average number of people in the store is approximately 14.4 shoppers. And so I have used units. I've restated all the numbers. I restated the answer and I restated the time intervals. And that would be a good explanation for this question.